Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Hi, I'm Lawrence Brown, Consultancy Services Manager with the team responsible for the delivery of this scheme. I have previous experience of designing for cycles, as I was the lead design engineer for the Western Cycle Corridor in Nottingham, which included innovative hardware and design practices.
And I'm Alex Moody, technical engineer and lead traffic signal designer for the Cycle Superhighways in Cardiff. I had little cycle experience before taking on this scheme over a year ago, but have since learned a lot of new information, and I'm now considered the cycle expert in the team.
Our presentation today focuses on innovation design practices to implement modern cycle infrastructure. We'll start by discussing the recent design works that we have completed in Cardiff, including a pop-up cycleways as a response to the current climate. We'll finish with video footage of innovation solutions which have already been implemented in Nottingham.
In 2018, Client Earth challenged the Welsh Government on the high level of carbon emissions in its capital. A recent Birmingham University study found that the carbon dioxide measured in Cardiff was worse than those measured in London. As a result of this, an agreement was reached where Wales promised to lower their carbon emissions as soon as possible. Following this, some major employers in the city planned a relocation to the city centre, notably the BBC Wales headquarters and the main HMRC building for Wales. This, along with a number of other employers, will bring in an estimated 10,000 jobs to the city centre. To lower the emissions, but to ensure suitable commuting times, a new, state-of-the-art cycle network was proposed. This cycle network will consist of at least 4 major routes linking the suburbs and hospital to the centre of Cardiff. A grant of £21 million was awarded to Cardiff Council to clean up the capital's air pollution. Included in this are the funds to complete the installation of brand new traffic infrastructure across the city, incorporating the new cycle requirements. One of the cycle highways in Cardiff is named Central Square. This is a loop of segregated cycle lanes linking arterial routes to the newer employer complexes and bus station. So the challenge. Cardiff Council produced models that show up to 10,000 cyclists a day in this area. Being the centre of the capital city and the high number of employers in the area, a high number of pedestrians is also predicted. The 2-metre wide one-way cycle lane runs parallel to the road, but deviates away behind the bus stops, creating a bus stop island. There is therefore a challenge of pedestrians crossing north from the bus stop island to the pavilion. The client expressed concerns over compliance with the zebra crossings in this location, especially where pedestrians are visually impaired, where there is no tactile feedback to indicate to cross. Therefore, a signalised pedestrian crossing is proposed. This crossing will have to adhere to local and national requirements and indicate to the visually impaired. Over to Loz to tell you a bit more about the crossing in depth.
We're proposing to use near-sided pedestrian display units as far-sided signal heads. As the crossing length is so short, using near-sided signals on the poles will have similar visual impact as a far-sided pedestrian signal head would have on a traditional crossing. High and low-level signal heads will be used to control the cyclists. The high-level signal head would be considered as the primary, as it will be the most visible on approach to the signals, and the low-level signal assumes the role of secondary, as it's what the cyclists look at while waiting at a stop line. we're proposing to use Siemens Heimdall narrow beam cycle detectors in replacement of conventional MVDs. The reason for this decision is that we require low speed thresholds to ensure slower moving cycles are detected without detecting pedestrians on the footpaths. The narrow beam characteristics of the detector ensure the detection zone will be limited to the cycle lane only. All other aspects of the crossing are in line with traditional pedestrian crossings. There will be right-hand push buttons with rotating tactile devices and curbside detectors to cancel any unwanted demands. Far-sided wait boxes are proposed for placing demands, as this crossing should be considered as a far-sided crossing. Here are some CAD mock-ups we've produced to depict how the crossing would look. As the use of near-side indicators as far-side signals does not conform to regulations, we needed to gain approval from the Welsh Government. These drawings were used as part of our submission to the Welsh Government for trial approval. Please take a few moments to look at these proposals. In addition to the central square cycle route, there are further routes in Cardiff which are benefiting from improved cycle infrastructure. These routes include a mix of signalised junctions and pedestrian crossings, all with cycle signal equipment proposed. The current scope of works includes the provision of further cycle routes following the successful implementation of the central square cycle route. However, the COVID pandemic generated a requirement to provide pop-up cycleways in addition to the originally proposed cycle routes. The pop-up cycleways are to be introduced to discourage the use of public transport, which makes social distancing difficult, and encourage the use of cycles, where social distancing is much easier. The pop-up cycleway equipment is to be added to existing signal intersections by adding cycle signals and detection where necessary, and junction reconfigurations. The introduction of pop-up cycleways does have potential to create further challenges, namely cycle congestion on the network, which would work against the original purpose of the scheme by making socially distancing difficult to maintain. In addition to the new street furniture onto the site, network operation will be biased towards a cycle traffic instead of vehicular traffic. This will be achieved through the use of strategies which could implement a hurry call or dataset triggering, for example.
Now that we have exhibited a unique proposal of pedestrian signals on a crossing over a cycle lane, we shall move on to looking at innovative design solutions on more traditional cycle infrastructure. The work we have previously completed in Nottingham used more conventional signal layouts but have more inventive detection methods. At junctions, cycle-specific wireless micro radars were used to ensure bites of all materials were detected. The use of micro radars over above-ground detection meant that the detection area was far more precise and forward demands could be placed for the appropriate stage at the junction. The cycle corridor in Nottingham differed from the Cardiff example we have discussed in that it was two-way. To overcome erroneous detects of cycles travelling in the opposite direction, multiple sensors were used and the detection points were configured to be unidirectional.
Following on from Alex's introduction, this is an existing cycle superhighway in Nottingham that Siemens has completed. To give a bit of context to the cycle corridor, the route is approximately 1 mile long, has 5 pedestrian crossings and 1 junction. The junction is installed with WiMAG cycle detection. The reason WiMAG cycle detection was the most sensible choice is because it can be quite difficult to cut loops in such small width lanes, and as the WiMAG cycle detector detects all types of bikes and not just metal ones as it is radar based. As the cycle lane is two-way for cycles, it can be quite common for cycles to cross into each other's lanes. For this reason, we installed 2 studs close to each other and configured them as unidirectional. When waiting at the stop line here, you can see the high and low level cycle signals. If you look on the primary pole for the vehicle phase, you'll notice a warning sign for vehicles to wait for their signal and not to be confused by the cycle phase signal. The cycles are in their own stage through the junction to ensure there is no conflict with vehicles turning left across them. Road markings designate the cycle lane through the junction as not to cause any confusion for cycles. And off we go. You'll see here that there is a bus stop with an uncontrolled crossing. This is different to the Cardiff solution as they will have controlled crossing points at all of these similar locations. You may notice that the cycle lane passes over a lot of side roads. These areas are all highlighted with green high friction surface, and cycles always have priority and vehicles have to give way. Now you can see I'm approaching a pedestrian crossing. This is a normal crossing with no specialist detection. The crossing is fitted with a standard above ground vehicle detector for the vehicle phase and the cycle phase, as the crossing runs VA and will extend for cycles and vehicles accordingly. However, given the current social distancing requirements, you don't want a lot of cycles in close proximity waiting at the stop line if the vehicle cycle green has ran to its max. The solution to overcome this is we are offering to change the above ground vehicle detector for the cycle lane to a cycle lane specific Heimdall detector. We would then configure this detector to hold the crossing to a higher maximum green time than vehicles if a cycle is detected, to stop multiple cycles waiting at the stop line. The benefit of having segregated cycle lane is that the cyclist gets good visibility of traffic moving in adjacent lanes and the safety of knowing they do not have to give way to cars. As you can see, there are not large quantities of pedestrians and cycles in this area, so it was not deemed necessary to have controlled pedestrian crossings to cross the cycle lane on this route. But you do still get the odd pedestrian wandering in the cycle lane, as can be seen here, so when designing the infrastructure required, this is one of the key things to consider. As you can now see, we're approaching the first pair of YMAG studs. These are spaced evenly apart for the UD functionality. As the site runs VA, these are the first studs that act as the stage demand. The distance from the stop line was chosen using a suitable cruise speed. One of the key considerations for this was, if the signals were on all red due to the absence of demands, the cyclist would get a green once they got to the stop line. Now at the stop line, the second set of studs are activated. These are treated as a conventional stop line detector and will demand the stage if a cycle misses the earlier studs. Again, from this location the cyclist has good visibility of their surroundings. All of the cycle detectors on this corridor have been configured to count the number of cycles and feed this back into the central system. This data could be used to influence strategies in UTC and Stratos, or just to get a general number of how many cycles are using the cycle superhighway. Following on from our earlier discussion around modifying the detection at a pedestrian crossing to include hurry calls for cycles to extend the vehicle and cycle green, the same principle could be applied at this junction. Generally, when approaching the junction, the cycle phase will likely be on red as there is a high traffic demand in the day. What we would propose to do at this junction is configure the entry studs to input an emergency vehicle priority move to force the junction to call the cycle stage. This would limit the amount of time a cycle user would have to wait at the stop line in close proximity to other cycle users. Obviously, there would be limits on how many times this could be implemented in a certain time frame as not to cause constant disruption to vehicle users, but every little helps to achieve the end goal of improving social distancing.
Thank you for watching our presentation.
Please feel free to ask any questions.